Hello, if you are dealing with uniform acceleration motion, you can use the equations of motion, also called the SUVAT equations, to do all the calculations. So why is it called the SUVAT equations? Well, because S for displacement, U for initial velocity, V for final velocity, A is the constant acceleration, and T is the time. So these are the 5 parameters that you'll find in the SUVAT equations. In total, there are actually 3 SUVAT equations. First, I want you to notice that the initial velocity and the acceleration are fixed for a particular uniform acceleration motion. So the one that links velocity with time is called the VT equation, or at least I call it the VT equation. The one that links displacement with time together, I call it the ST equation. And the one that links final velocity with a displacement, that's called the VS equation. A lot of students like to ask, it's so confusing, there are 3 of them, I don't know which one to use. Yeah, it comes with experience, but roughly speaking, if the information given to you is V and T, or if you are trying to link V and T together, then use the VT equation. If you are trying to link displacement with time together, then use the ST equation. If you are trying to link the velocity, final velocity, to the displacement, then use the VS equation. Yeah, but as I said, it comes with experience. So let's do an example to gain some experience. Alright, so this is the question here. Read it first, yeah? Okay, so we are told that there's a car. It starts off with a velocity of 8 meters per second rightward. Now, if we are using the rightward is positive sign convention, that means U is equals to positive 8.0 meters per second. And then we are told that the car has a constant acceleration of 3.0 meters per second square. So that is the constant acceleration, but the acceleration is in the leftward direction. Yeah, so if you are using the rightward is positive sign convention, then our acceleration has to be represented by the negative number. So it's negative 3.0 meters per second square. Now in this part here, we are asked to calculate the velocity V at t is equals to 5 seconds. So we are trying to link V and time together, right? So which equation should we use? Obviously the VT equation. So V is equals to U plus AT. Let me write it out first. Let me write it out in bracket before we apply this equation and plug in the numbers. So we want the velocity. So write the velocity here. V is equals to U. So U is 8.0, a positive 8.0. Plus the acceleration is negative 3, yeah? So make sure you don't forget the negative sign. And and then we want the velocity at t is equals to 5 seconds, right? So put in t is equals to 5. Then press your calculator and you get the number negative 7.0 meters per second. The calculator is giving you an answer that's negative. What does that mean? That means it's a leftward velocity. Yeah, it makes sense, yeah, because we have this car. It starts off going rightward, 8.0 meters per second, but the acceleration is leftward, 3.0 meters per second. So if you think of the motion of the car, is going to be going rightward, but slowing down, slowing down, slowing down. Eventually, you'll come to rest, but the acceleration is still leftward, right? That means you'll turn around and move back. So that explains why we got a negative answer here. So the car must have already made the U-turn. It's on the way back at t is equals to 5 seconds. Okay, let's do the next one. So this time round, we are asked to calculate the time when the car is at 5 meters on the right. So what we are given here is we are trying to the 5 meters actually correspond to displacement of positive 5.0 meter. because we are taking the rightward, it's positive sign convention. So we are trying to link time with displacement. So which equation of motion should we use? Obviously the ST equation, yeah? So S goes to UT plus half AT squared. Let me write it out, bracket it up before I plug in the numbers. So the displacement I'm interested in is 5 meters. The initial velocity, remember, is 8.0, yeah? Time is what we're trying to calculate, plus half. Now the acceleration is negative 3.0, and then the t square. So we got to solve for t, yeah? Ayo, turns out this is a quadratic equation, so let's rearrange it a bit first. So hopefully you remember how to solve a quadratic equation. Is the thing that goes minus b plus minus b squared minus 4ac blah blah blah, that thing, yeah? So you get two answers, 0.723 seconds or 4.61 seconds. So which one is the correct answer? Both, right? Remember, we have the car going rightward, slowing down, comes to rest, and then makes a U-turn. So t goes to 0.723 seconds must be the first time when the car passes 5.0 meters. And 4.61 seconds must be the time when he's when he has made the U-turn. So the math is correct, huh? There are indeed two instances in time when the car was 5 meters to the right. Okay, let's look at the next one. So, so exactly when is the time instant when the car is at the furthest right position? So, obviously what we want to find is some kind of time. So, is there something special about the velocity or displacement when the car is furthest to the right at the extreme point? Do you realize that at the extreme point, the velocity must be 0? Because if the velocity is positive, it means the car is still going rightward. But if the velocity is negative, that means the car has already made the U-turn. So at the instant when it's at the furthest distance to the right, at that instant, velocity must be exactly equal to 0. So to link t and v together, we use the vt equation. So we are interested in the instant when the velocity is 0. Now the rest is plugging in numbers. Remember, the acceleration is leftward. So pick up your calculator. Turns out the number is 2.67 seconds. Okay, just one final one. This time round, we want the furthest distance reached by the car. Now in the previous part, we have already calculated the time instant when it's to the furthest right. So one way is to use the answer, use the ST equation and solve. But let's say we haven't done that calculation and we want to solve for this one in just one equation. How would you do it? So again, the motion is like this. The car is going rightward, slows down, comes to rest, and then makes the return journey. We know that at the furthest distance, velocity is 0. So if you want the displacement at this particular instant here, then you should use the Vs equation, isn't it? So V squared is equal to U squared plus 2As. So at the rightmost point, velocity is 0. So the rest is just plugging in numbers. Remember, the acceleration is leftward, so negative. So S is the unknown we are trying to solve for. So press your calculator. Alright, I hope you find this video useful. That's all. Ta-ta!